1952. A windowless room at Columbia University. A young American geologist named Maurice Tharp is forbidden from the research ship, so she is given the data instead, thousands of depth soundings of the Atlantic floor. She plots them by hand, line by line, and finds a valley running down the middle of the ocean. You have seen what she drew. It is on the wall of nearly every science classroom on Earth. The map of the bottom of the sea, the long chain of underwater mountains splitting the Atlantic, the deep crack running down its spine, and the fact her map helped prove that the continents are not fixed, that they move, is now the first thing a child is taught about the planet. In 1952, almost no geologist in America would say that out loud. Maurice Tharp found the evidence for it in a column of numbers. Her name went second on the map. Then it went missing. What you are about to learn is now printed in nearly every textbook on Earth, the shape of the seafloor. The woman who drew the feature at the center of it was told for years that what she had found could not be real. She was not allowed on the ship that collected the numbers. She mapped a place she was never permitted to visit. This is not a story about a woman who failed. Maurice Tharp was right, completely, provably right, about the biggest question in her science. She simply had to wait decades for the men around her and then the world to admit it. Tharp had degrees in geology and mathematics, a master's in geology from the University of Michigan, a degree in math from Tulsa, at a time when almost no university would let a woman near a field science. In 1948, she came to Columbia, hired by the geologist Maurice Ewing. A year later, his group moved to a new research center on the cliffs above the Hudson, the Lamont Geological Observatory. But Lamont had a rule. Women were not allowed on the research vessels. A woman aboard a ship was considered bad luck. So while the men sailed the Atlantic dragging instruments behind them, Maurice Tharp stayed ashore in a drafting room and was handed what the ships brought back: reels of paper and columns of numbers. Her job was to turn those numbers into a picture of a place no human eye had ever seen: the floor of the ocean. The numbers came from a device called an echo sounder. A ship sends a pulse of sound straight down, waits for it to bounce off the bottom, and measures the time it takes to return. Time the echo, and you know the depth beneath the keel. Cross the ocean firing pulses, and you get a single line. A profile, a vertical slice of the seafloor along the ship's track. Mountains and trenches rising and falling under the hull. Tharp's task was to take dozens of those crossings of the North Atlantic and plot them by hand, one profile at a time, until the shape of the bottom emerged. As she plotted, a feature kept appearing. Down the center of the Atlantic ran a vast submerged mountain range, the Mid-Atlantic Ridge, already known to exist. But Tharp saw something the existing charts did not show. Along the very crest of that range, in profile after profile, there was a notch. A deep, sharp, V-shaped cleft cut into the top of the ridge. And it was not in one place. It appeared in the next crossing, and the next, and the next, always at the center, always the same shape. Tharp was looking at a valley. A continuous valley, thousands of miles long, running straight down the spine of the underwater mountains. She knew what a valley like that meant, and it frightened her because it pointed at an idea her entire profession had spent 40 years rejecting. A long, straight rift, splitting a mountain range down its middle, is what you get when the ground is being pulled apart, when the floor on each side is moving away from the other. And if the floor of the Atlantic was being pulled apart, then the land attached to it was moving too. The continents were not nailed in place, they were drifting. It was the hypothesis a German named Alfred Wegener had proposed in 1912, and that American geology had mocked and buried ever since. Maurice Tharp had just drawn the evidence for it. She brought it to the man she worked beside, Bruce Heezen, the Lamont geologist who oversaw the data she was plotting. She showed him the rift. She told him what it meant, and Heezen did not believe her. The idea of continental drift was, in his field, close to a professional embarrassment. According to Tharp's own account, he dismissed her interpretation as, his words, girl talk. He told her she was wrong, and he had her redraw the profiles. Maurice Tharp drew the Rift Valley again. It was still there. The numbers did not change to suit anyone's comfort. What changed Heezen's mind was a second map. At Lamont, another line of work was plotting the locations of earthquakes. the epicenters of every recorded undersea quake in the Atlantic. When that map of earthquakes was laid over Tharp's map of the seafloor, the results stopped the argument cold. The earthquake epicenters did not scatter randomly. They ran in a line straight down the mid-Atlantic ridge, and they fell inside Tharp's Rift Valley. The planet was cracking exactly where she said it was cracking. The earthquakes were happening in her valley. There was no longer a way to call it girl talk. Heezen was convinced, but being right was not the same as being credited. Tharp had found the rift. She had drawn it, defended it, drawn it again. And when the work was finally published, the discovery did not go out under her name first. In 1957, the first physiographic map of the North Atlantic floor was published. The authors were listed as Heezen and Tharp, his name first, hers second. For years afterward, on the papers and in the institution's records, Marie Tharp was carried not as a scientist, but as a drafting assistant, a technician who drew what others discovered. She had discovered the central feature of the map herself. The crack down the middle of the ocean was hers. The credit line said otherwise, and through all of it, she still could not go to sea. She was mapping the floor of an ocean she had never been allowed to sail across. That did not change until 1965. After nearly 2 decades at Lamont, most of them spent drawing an ocean she was forbidden to visit, Marie Tharp was finally permitted aboard a research vessel. She was, by then, in her 40s. She had already mapped more of the seafloor than almost anyone alive. The first time she was allowed to float above the Rift Valley she had discovered, she had been studying it from a drafting table for 13 years. And then the science turned her way. Through the 1960s, the evidence Tharp's rift had pointed toward became undeniable. The seafloor was spreading outward from the ridge, the continents were moving. The entire surface of the Earth was broken into drifting plates. The thing American geology had buried with Alfred Wegener was now its foundation. It was given a name, plate tectonics, and it rewrote every textbook. And at the center of the picture, in every diagram of how the planet works, was the feature a woman had been told was girl talk, the Rift Valley down the mid-Atlantic ridge. In 1977, the work reached its summit. Tharp and Heezen, with the Austrian landscape painter Heinrich Berann, published The World Ocean Floor, a single panoramic painting of the entire bottom of the sea, ridges and trenches and abyssal plains laid bare as if the water had been drained away. It became one of the most reproduced scientific images ever made. It hangs in schools and ministries and museums around the world. The name printed largest on it was Heezen's. That same year, 1977, Bruce Heezen died at sea, near Iceland, aboard a submarine, surveying the ridge. Marie Tharp lived on for nearly 30 more years, and slowly the record was corrected. Late in her life, the Library of Congress named her one of the greatest cartographers of the 20th century and put her maps on its walls. The honors came, most of them decades after the discovery, most of them after the man whose name went first was already gone. She had drawn the bottom of the ocean. She had found the crack that proved the continents move. And she had done it without ever, in those first 13 years, being allowed to look at the sea she was mapping from anything but the shore. Marie Tharp died in 2006. The map she drew is still on the classroom wall. The valley she found is still at the center of it. For 13 years, they handed her the ocean as a column of numbers and would not let her near the water. She drew it anyway, and she got it right. Case files on the people history forgot to thank. New cases every week.